Hi guys, and here are the 3.2 notes solving linear systems algebraically. From our pretest, it looked like a few of you did remember some of the methods as to how to solve systems algebraically. So let's get right on into them. Method 1 is substitution. Okay. Pretty self-explanatory. You're substituting one method or one variable in for another. And really when it's most useful is when one or both variables have a leading coefficient of 1 or -1. So we'll see that here. Notice in our first example, solve the system using substitution. The x has a leading coefficient of 1. And where's that at? It is right there. Okay, this x really has a fancy little 1 in front of it. That makes it nice and easy to solve for. So what we can do is move everything that's not this x to the other side, meaning that x is really, if we subtract 4y, it's really -4y plus 2. That is what x truly is. Now, we didn't really solve anything just yet. We just remade it so it's easier for us. So we're going to take our other equation now, 2x plus 1. And keep in mind, we just found that x. So I'm going to show you with the different colors essentially what we're doing. Okay, we found x. So that means we can substitute it. Okay, so x is really -4y plus 2 equals 5y, plus 5y. That is a common little mistake there. Equals 7. Everything else stays the same, but we substituted x in there from what we solved originally. Okay, the big thing here is to remember to distribute the 2 to everything inside. So 2 times -4 is -8y plus 4. And then don't forget about this 5y at the end, equals 7. Now if you substituted right, you're just going to have one variable. Notice we got rid of the x's. We just want all y's in there for right now. Okay, add our like terms. This is all the math coming together now. -3y plus 4 equals 7. Solving for y. And y equals -1. Common tendency, students stop there, but we need to still find the actual x value. Okay, before we just found its substitute. To do that now, well, we know x is equal to -4y plus 2. We found that y is really -1, and that means x is 4 plus 2, x equals 6. The solution then, remembering how to write it out, is 6, -1. Okay, this would be a good point to double check your answer by substituting into the original. Our second example of substitution is a little bit different in that notice that the y actually has a leading coefficient of -1. Doesn't make it too much harder, but again, if you want to solve for y by subtracting 3x, we have -y equals -3x plus 2. you just need to divide by -1 in order to make it a positive y. Now be careful. Y then is 3x minus 2. And we will use that y to substitute into the second equation anywhere that we see y. So 6x plus 3 times 3x minus 2. Remember, that's our y that we just found. Plus or equals 14. And again, don't forget to distribute to both terms. And that will leave us with 6x plus 9x minus 6 equals 14. Be careful. Again, most of the time, the little mistakes will come from distributing. 15x equals 20. Divide by 15. Divide by 15. X then equals 4/3. Leave as a fraction. That will actually help you. But don't forget to find y. And we know y is really 3 times our x minus 2. You again can use any equation, but since we solve for y, we'll use it. 3 times 4 is 12/3 minus 2. Well, that's really just 4 minus 2, and y equals 2. So again, don't be a hero necessarily. I know a little bit of math, so I did, of course, fractions by hand. But if you get fractional answers, that is a good point to double check, perhaps. Okay, so maybe I'll come back to do that later. 4/3, 2 is your x and y combination. We're actually going to skip the real-world connection for it right now. We'll call it a challenge. Okay, and I'll come back to it a bit later if you have the time. Method 2, instead of substitutions, known as the elimination method. Elimination. This method is more useful when coefficients in a system can be canceled out by addition or subtraction. Okay, and particularly if the leading coefficients are not 1 or -1. In most cases, you'll need to multiply by a constant in order to create opposite coefficients. Now you have your choice, okay? You can be one to either eliminate x, or you can try and eliminate y. But notice which one might be easier. So, both of our x terms have a leading coefficient of 2. Okay? That means we can easily cancel them out if we multiply one of the systems by a -1. So you can again choose. Alright, it's all about choices. So I'm going to choose the second system. Yes, Phoenix, I hear you. And I'm going to multiply it by a -1. Please rewrite your work. I know it might be a pain in the butt, but honestly, the neater you are with these equations, the better it will be. Okay? So, I distribute my -1, and we'll see why I decide to do that. And don't forget to distribute to the last number as well. So now, if I were to add these two systems, my 2 and my -2 are going to eliminate one another. Okay, so really 2x minus 2x is 0x. Okay, you don't even need to write it really. 6y plus 10y is 16y. And 17 minus 9 or plus negative 9 is equal to 8. From there, we'll divide by 16. Y equals 1/2. Okay? Now again, don't forget to find x. That's just half of the puzzle. So once y is found, just use either equation. You can use equation 1 or 2. Either equation is fine, and we'll substitute it. So 2x plus 6 times 1/2 equals 17. Be careful, most of the time it's simple algebraic mistakes that lead you off. I am certainly guilty of many of them myself. And x equals 7. Properly written as a solution, 7 1/2. Okay, so that's the basic elimination. It does get a little bit more difficult. That's the terminator. Okay, so notice, none of our leading coefficients are, opposite or anything like that. So none of the coefficients are 1 or -1. So we want to think about the elimination. And also, we don't have anything that's really nice and opposite of one another. 4 and 6 aren't related. 5 and 2 aren't related. So we actually have to multiply both equations to try and make them. Again, you have your choice. Do you want to eliminate x or y? Okay, you have your choice. I am going to choose to eliminate x. Get rid of the x terms. To do that, so there's 1, here's 2. In order to do that, I will simply multiply the first equation. I need to get 5 and 2 to be opposites with the coefficients. So simply put, if I multiply the first equation by a 2, let me rewrite it here. And I'm going to multiply it by a 2. And the second equation, I'm going to multiply by a 5. What that leaves me with is 8x minus 10y equals 26. And red becomes 30x plus 10y equals 5 times 48. Oh boy. $240. And once we have our opposites to add, so notice this is negative 10y, that's positive 10y. That's what we wanted. If we now just add straight on down, 8x and 30x is 38x. These are eliminated. 26 plus 240. Let's see here. $266 divided by 38. Divide by 38. And it looks ugly, but x is really just 7. Don't forget to do what? Find y. Okay, again, you can use any equation. Use any original equation. And I will simply choose the first one, 4 times the 7 minus 5y equals 13. 28 minus 5y equals 13. 13 minus 28, negative 15. And divide by negative 5. Y equals 3. Properly written 7, 3. Okay. Elimination. You have your choice, either X or Y. These take a lot of practice. The last thing I want you guys to see before I get into the optional is remembering that some systems don't have any solutions. Okay, if they don't cross one another, we called these systems either parallel or inconsistent, because we're looking for a solution, but it's inconsistent. There is none. Okay, so it's really just no solutions. But if you see the word inconsistent, that's all it means. And notice, okay, if you go to solve this by elimination, so if we multiply by the negative 2, okay, let's choose the first one to multiply by negative 2. What does that leave us with? Negative 6x minus 8y equals negative 36. Okay, the second one we don't do anything with. 6x plus 8y equals 18. You go to eliminate, you're like, haha, negative 6 and positive 6, gone. Okay, so we have no x's. Also, negative 8 plus plus 8, those are gone as well. We have no y's. But we're equal to negative 18. Okay, students tend to forget 0 plus 0 is 0. Is that equal to 18? Okay, 0, is it equal to 18? No, negative 18. So, since that is not a true statement, there are no solutions. Okay, don't be afraid if you get something like that. If the variables cancel out, so the variables all cancel, and you're left with a number on the other side. Okay, that is no solutions. We will be working in class on cases of infinite solutions, and it's just a little tiny bit different. But very good. Thanks for hanging in there. A lot to go through. You probably remembered a good bit. You certainly can answer the EQ now. I am going to go back and double check some things, and also go through the challenge, but you are free to go.